Right. So from this given question from travel graphs, you're given that the graph shows the path of the velocity, a time graph of a moving object. Remember, you can just say object or something which moves, or even you can just say a car. The graph shows the path of the velocity time graph of a moving object or moving car. The object travels at a constant velocity of v um, meters per second for v meters per second in 10 seconds. For v meters per second, in 10 seconds, right? V meters per second in 10 seconds. So it's supposed to be v meters per second for 10 seconds. It then accelerates. So we're just saying the graph shows the part of the velocity time graph of a moving object. The object starts from point V, which is unknown. The object travels at a constant velocity of v meters per second in 10 seconds from this up to 10 seconds. It then accelerates uniformly until it reaches this velocity of 50 meters per second, which is here. Then in 4 seconds, 40 minus 10, you get 4 in 4 seconds. Then you ask it to the distance traveled during the first 10 seconds. The distance traveled within the first 10 seconds is 50 meters. Cover the value of v. Find the acceleration during the last 4 seconds. For the last 4 seconds, then total distance traveled by the object in 14 seconds. So let's move on to the solution, considering a step by step. Right. So for the solution, so basically when dealing with those solution analytic travel graphs, basically what you have to know here is let me just give you the basics we are going to focus on. First of all, you have to know how to calculate the acceleration. Acceleration is same applies to gradient. Just imagine the car is moving and it is something like a mountain, and that car wanted to climb that mountain. The moment the car wanted to climb the mountain, or I think a hill, a car wanted to climb a hill, moving on upward. So the car changes its gear, increase its velocity, right? So it started to accelerate because it's moving on a positive gradient. At some point, the car wanted to decline. It also changes the decrease in gradient. So what you are saying here is, whenever dealing with what you call this, we have to know acceleration, change in y over change in x, increase in y over increase in x, or we have to write the formula for gradient, or y movement of x movement. That's the formula for acceleration. The formula for acceleration is same applied to the formula for deceleration. All right. So, at some point, you may be asked to calculate the distance covered. Distance covered is equal to the area under the graph. So what you have to be familiar with is, you have to check if it's distance covered in 10 seconds. Yes, the shape is here for 10 seconds. If it's 14 seconds, the shape is here. So be familiar with the shape. Right. So from this shape, the shapes we are familiar with here is the first formula we have to know is a side by side square, length times width rectangle, and also a half open bracket a plus bh, which is what you call trapezium. So area for triangle, you have to know the area for triangle, half base times height, area for square, side by side, a rectangle, length times width, and also trapezium, half AB, half B plus half A plus B open bracket H. Those are the formulas you should be familiar with here. Right. So for the first question, let's attempt the first question. For the first question you are given, the distance traveled during the first 10 seconds is 50. So you are given the distance traveled during the first 10 seconds. Where is the 10 seconds? The 10 seconds is just here. That's the first 10 seconds. What's the name of this shape? Yes, it may be sounds like a square. Also, it sounds like a rectangle. So if you don't know if it's a square or it's a rectangle, we have to just use you are supposed to use the formula for rectangle. If it's a square, you get that these two sides are equal. If these two sides becomes equal, means to say the shape is a square. If the sides are not equal, this is 10 and this is above 20 or below, or this is above 10 or below 10, the size becomes a rectangle. So let me just for this, since you asked to calculate the value of v, want to calculate the value of v, So I can just say, for me to find V, I can just say length times width is equal to, right, where is the length? The length is 10, um, length times width. So I can just say 10 times width is V is unknown, times V should be equal to, remember I said before, distance covered is equal to area under the graph. So the area times width. So 10 times V is equal to, we are given that is 50 meters. To find V, 10V is equal to 50 meters divided by 10. Divided by 10. V is equal to 5. Now V is equal to 5. So here we have 5 here. We just put a small 5 here. Here is 5 meters per second. That's V. Right. So from this given V, find the acceleration during the last 4 seconds. Acceleration. Yes, the object was just moving on a constant velocity. Yes, it was not increasing and it was not decreasing, but it was moving at a constant velocity. From there, it started accelerating. We want to calculate the acceleration during the last 4 seconds. Where to get that 4? We are just subtracting from this point to this point. We are just saying 40 minus 10, you get 4. Right? So, this minus this for the, right, 50 minus 5. So we are just saying, which is B item 2, B item 1. So acceleration equals, we can just say change in y over change in x. Change in y over change in x. Simple substitution for y, change in y, we just say 50 minus 5, which is v. 50 minus 5 over, to get 4 here, 40 minus 10. This becomes 15 minus 5, we get 10, over 14 minus 4, you get 4. This becomes 2.5 meters per second squared. That's what's called the acceleration for the last 4 seconds. So from acceleration, let's now move on to the last question. Find the total distance traveled by the object in 14 seconds. From this point, which is 10 seconds to 40 seconds. So we want to find this area, because distance covered is equal to area under the graph. We want to find the area under this. For the area, I think it's wise for us to, I can just make it easier. I just add this area plus this area. Area of a rectangle, yes, rectangle, both 5 here, 10 here. Area of a rectangle plus area of a trapezium, or I can just divide here to form area of a, I can just say length times width here for rectangle. Then now I have 14 minus this one, I have 4. Then from this 10, also length times width. Then area for this, the upper shape, which is half BH, half base times height. Half base times height. So for me to calculate the total distance covered, I have to say total distance equals total distance equals total distance equals to area covered by the area covered by the object. Area covered, this becomes, for the first area, length times width, length by width plus length times width plus half BH. This is equals to length times width for the first one. But remember, the area for the first shape in 10 seconds we are given here is 50 meters. 50 meters plus length times width for this. Length times width, which is 4 times 5, you get 20. 40 minus 10, you get 4 here. Times 5, you get 20. 20 meters here plus half BH. Half base, where is the base? Base is 4 here. terms. Here we have 10, 15 minus 5, we have 10 here. So half of 10 is 5. 5 times 4, we also have 20 meters. This becomes 20 plus 20, you get 40 plus 50, you get 90 meters. That's the total distance traveled by the object in 14 seconds. So when dealing with the travel graphs, basically what you have to know here is anything to do with the distance traveled, anything with to do with the distance traveled, think about the area covered by that object. Think about the formulas for the given shapes. Is it rectangle? Is it square? Is it triangle? Is it trapezium? Any shape, be familiar. If you don't know how to apply a formula for trapezium, you have to divide like what I did here to form two shapes. You form whether a square and a triangle, or you form a rectangle and a triangle. You add those, this area plus this area plus this area. Then you come up with the distance covered. So basically, to do with travel graphs, this is what you are supposed to do. This is what you are supposed to apply. Whether you ask it to find the acceleration or deceleration, this is what you are supposed to apply. Before I end this video, I think it's time for you to think about this formula. V is equals to U plus AT. There is a question based on this. Where do I apply V is equals to U plus AT? Where V is the final velocity, U is the initial velocity, A the acceleration, T is for time. On my next video, I will just send a lesson based on where to apply this. Yes, it's also applicable to this. Because at some point, you might be asking for acceleration, initial velocity, final velocity, or even time. But I'll just send a lesson based on application of V is equal to U plus AT. The application of what you call this formula for kinematics. Right? So I think it's time for you to share my video, also to like, comment with your topic you want me to upload. Also, don't forget to visit my YouTube. That's where I upload more video on that platform. So enjoy the lesson. For those who want to get in touch with me to learn through my online class, I use WhatsApp. I upload videos on different platforms, but I use WhatsApp for online lessons, which is reliable, guaranteed high pass rate, no history of failure. A, pass with the A, fail with the B. So enjoy the lesson based on this. June and November exam preparation, we have started on WhatsApp. WhatsApp me, 77814522, 77814522, or you can just take my number on my TikTok or YouTube bio. Take my number, message me, and start learning today. Enjoy this video. Thank you so much.